hello, check, check. Hello, check, check. Hello, check, check. Hello, check, check. Hello, check. Hello, check. Hello, check, check. Hello, check, check. Hello, check. Hello, check, 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 hello, check, hello, check. Hello, check, hello, check. Hello, check, hello, check, hello, check, hello, check.
ఎక్కడ ఉంటుంది? దీని నుంచి వస్తుంది కదా మైక్. ఇదే కదా మైక్ సెట్టింగ్స్. ఛానల్ 1 2 జస్ట్ ఇది ఒకటి ఆఫ్ చేసిన. ఇంకోటి 1
కేబుల్ దేనికి పెట్టాడు?
హలో హలో చెక్ చెక్.
కేబులే పెట్టలేదు దీనికి, మైక్ కేబులే పెట్టలేదు. ఆడియో ఎలా వస్తుంది?
హలో హలో చెక్ చెక్.
రెండు ఇన్పుట్లు వస్తుందా? దీనికంటూ మైక్ ఉంది ఇక్కడ.
హలో హలో చెక్ చెక్. హలో హలో.
ఈ ఛానల్ ఎంత? ఇన్పుట్
1లో ఉంది. ఇక్కడ 1 ఆన్లోనే లేదు, ఆన్లో పెట్టారు.
ఈ ఛానల్ 1 కదా.
ఇన్పుట్ 1 10 dB పెట్టండి.
లైన్ అంటే
మైక్, దీనికి ఇన్బిల్డ్ మైక్ ఉంది ఇక్కడ.
ఇన్పుట్ 2 ఛానల్ వాడతలే మనం, ఓన్లీ 1 ఒకటే. 0 dB అంటే ఎక్కువ వస్తుంది సౌండ్.
హలో హలో చెక్ చెక్.
5 లైన్. ఇప్పుడు చూసి సౌండ్ ఏమైనా డిస్టర్బెన్స్.
ఫైవ్ డీబీలో పెట్టాను చూడండి.
5 dB. హలో హలో చెక్ చెక్.
వస్తుందండి.
హలో చెక్ చెక్. హలో హలో చెక్ చెక్. హలో హలో చెక్ చెక్. MeitY. Hello, Kalyan, mic volume check.
తగ్గియాలా వాయిస్?
Again change చేయకు.
వాల్యూమ్ తగ్గియాలా?
No. check.
వాడు అవుతుందా అది?
Hello, check, hello. Hello. Hello, check.
ఇప్పుడు ఇంకో వాల్యూమ్ ఇది ఉందా, ఇది మొత్తం తీసేసిన అనుకో ఏం సౌండ్ రాదు. ఇప్పుడు రాదు, కొంచెం సేపు ఇప్పుడే తగ్గించిన. ఇప్పుడు ఒక 5 నిమిషాలు అయినాక ఇవ్వరా సార్.
ఇంకోటి ఏంటంటే ఇన్పుట్ ఆడియో రికార్డింగ్ లెవెల్ ఇంకేంటి కాదు ఇన్పుట్ 1
ఇది ఆఫ్ చేసిన, ఇన్పుట్ 1
ఇది దానిలో ఉందా కిందకి ఛానల్ 1
అది
ఇక్కడ
ఛానల్ 1
ఇన్పుట్ మైక్ ఉందా చూడండి.
అది ఛానల్ 1 ఉందండి కళ్యాణ్. ఛానల్ 1 కదా మరి, నేను అది మైక్ పెట్టింది.
అంతేనా? కాదు ఇక్కడ మైక్ సెలెక్టర్ ఉన్నది కదా, దీంట్లో ఆటో ఉంది, ఇన్పుట్ మైక్ ఉంది, ఎంఐ షూ మైక్ అంట. ఎంఐ షూ మైక్
మైక్
స్టీరియో మైక్ మినీ మైక్ అంటే
ఏమన్నా మైక్ పిన్ ఏమైనా ఉందేమో ఇంకోటి.
అది ఆక్స్ పిన్ ఉంటుంది, ఇగో ఇదే ఉంటుంది.
సాక్స్ ఇది.
అది హెడ్ ఫోన్ అది.
మరి మైక్ ఎక్కడ ఉంది?
మైక్ ఇదే, ఇవి రెండే.
మైక్ సెట్టింగ్ మళ్ళీ మార్చాలనుకోండి. పడుతుంది.
మైక్ సెలెక్ట్ ఉంది కదా, ఇన్పుట్ మైక్ ఉంది కదా, అది సెలెక్ట్ చేస్తే వస్తుంది ఆడియో. ఇది పెడితే ఎంఐ పెడితే రావట్లేదు.
ఇప్పుడు అలా సౌండ్ వస్తుందా? అలా హలో హలో అని చూస్తే తెలుస్తుంది కదా ఒకసారి కదా. అలా హలో హలో అంటే వస్తుంది.
ఛానల్ 2 ఉంది కదా, ఛానల్ 2 కూడా డౌన్ చేయొచ్చా? ఆఫ్ ఏం లేదు,
రెండు ఆన్లోనే ఉన్నాయి.
ఇది వస్తుంది ఛానల్.
ఇక్కడ ఒకటి ఉంటుంది ఇప్పుడు బటన్, ఛానల్ 1కి ఇటు సైడ్ ఉంటుంది, ఛానల్ 2కి ఇటు సైడ్ అని ఒకటి ఉంటుంది.
ఇటువైపా ఏమో మైక్ ఉన్నది. ఈ మైక్ అది పెడితే ఇలా వాడు ఇచ్చిన మైక్ ఉన్నది చిన్నది, ఆ మైక్ ఇలా పెడితే అసలు
ఇంకా దేంట్లోకి వెళ్ళి వస్తుంది వాయిస్.
దాంట్లోకించి రాదు రాదు.
దీనికి రిమోట్ ఇచ్చిండు కదా అదే
వినబడుతుంది. ఈ పెట్టకపోయినా కూడా వినబడుతుంది.
సేమే అది పెట్టినా పెట్టకపోయినా మనకు మైక్ యాక్టివేట్ కావాలి ఇనిషియేట్. కెమెరా ఒకటి ఉంటుంది తీసేసి ఇంకా బటన్స్ ఏమో ఉన్నాయి
హలో హలో ఇగో నేను మాట్లాడింది లెక్క వస్తుంది ఇప్పుడు ఎక్కువ. హలో హలో అసలు మైక్ మాట్లాడు.
హలో చెక్ హలో చెక్ వస్తుందా?
Ma'am, kindly sit in the starting benches. Sheikh China, ma'am. Come here. All the floor students come to starting.
స్మూత్ ఉందా?
ఇప్పుడు మాట్లాడు.
హలో చెక్ హలో చెక్ ఇక్కడ ఓకే అన్న. హలో చెక్ 1 2 3 హలో చెక్. సరిపోతుంది కదా.
ఇప్పుడు మాట్లాడు. ఇప్పుడు మాట్లాడు. మైక్
హలో చెక్ హలో చెక్.
లైట్ తీసుకో చాలు. చాలు ఇక ఏమవుతుంది అట్లనే ఉండండి. సరిపోతుంది అది ఎక్కువ మంచిగానే వస్తుంది క్లియర్. రికార్డింగ్ అదే అంటున్నా. ఇప్పుడు కెమెరాలో వచ్చే రికార్డింగ్ సౌండ్ అంతా దీంట్లోకి వెళ్ళి మనకి ఫోన్లో వస్తుంది. ఇక అది అవసరం లే. ఇక చాలా సౌండ్ మళ్ళీ మొత్తం గర్ అని వస్తుంది. ఎక్కువ పడుతుంది. ఇది కొంచెం క్లీన్ ఉన్నది. ఇది సైలెంట్ ఉంటే సరిపోతుంది మనకు. చార్జ్ చూపించాలి.
Ma'am, I said you to sit here, not there. I hope you understand it. Any student with a notebook can leave.
NIT Warangal. His research areas are signal processing, control system design, and edge AI. He has published national and international papers in various national and international journals. He is also the principal investigator for the CERT Government of India, and the project cost is 19 lakhs 80,000. He got the Best Paper Presentation Award, DST Young Scientist Travel Grant, and many more. Now, I would like to hand over the mic to Professor Ravi Kumar Garu.
అందుకని ఒకసారి క్వాలిటీ చూస్తే మనకి ఆప్షన్ అనిపిస్తుంది.
So very good morning. So I did my BE 99-2003 in Vasavi College of Engineering. Okay. So at that time, I think you are correct, huh? Your date of birth would be somewhere 2005. So 99-2003, I did my BE. We had a professor called Professor Venkatramaya, and he's PhD from IIC Bangalore. So I was, a student, came from village, Torur district, Torur Mandal of Warangal district. So Ms. Venkatramaya, he forcefully sent us all seminar topics. Vasavi College, still it is like a school now, right? But job is guaranteed. Ibrahimabad. Okay, so our professor used to send us to conferences, learn something in the seminar topic. So we used to, for attendance sake, we used to go to the seminars. And whenever we get time, so we thought of escaping out of it. As a result, I became lecturer. Right? Whatever they would have said, I followed and learned little bit knowledge or advance. Then I would be somewhere around in any company doing my work, but now every day like I am a student, right? During my time, there is no machine learning. I didn't study any machine learning course. I didn't study any convolution neural networks. But now I supposed to every day, along with my kids, I'm studying up to 12 o'clock. So the summary is what? Whenever you have to study, if you are not studying, you need to study again and you will become lecturer. Okay? But when chance is given, if you utilize, you will be somewhere else. So by force you are here, or by chance or choice you are here. You be with me for 4-5 hours. Definitely, at least 3 to 4 guys I'll give internship at NIT Warangal. Pakka. And maximum I'll try to make it interactive. Something is happening, the name is faculty program, and it is given to us. Don't think of it. Learn this, which is the order of the day. Okay? And with Python coding, I'll be explaining the concepts of this. So I'm going to cover neural networks and convolution neural networks from the basic. Okay? So you feel key, this is my subject or my order of the day. If I know these things, it will helpful for my life. That is what you think of. And as the time goes on, the front benches should fill. Let us take it as a challenge. Okay? So, or otherwise, you interact, ask a number of questions. Okay? I'll be answering. Okay? Because morning 6:30 I started from Warangal. 6:30 when I started means at what time I woke up? Around 5 o'clock to reach KL University. Because the task given for me is this, right? So let us make this session interactive, which is helpful for you. I'll tell you why you should attend these seminars or some conferences and all. So I'll tell you a story, small story, I'll start. Earlier days in 1950s and 60s, there are no television, mobile phone and all. But knowledge transfer should take place. How? Right, dharma move. Why we have to do these things? So earlier, pravachanalu used to be there in the villages. Right, so some knowledgeable guy, he used to come and then he used to give certain like niti idi, dharma idi ani cheppevaru. All are Telugu only? No? Yeah. So in that case, in one village, this Harikatha Puranam, we used to call it as Harikatha Puranam, where they used to teach the Bhagavatam and all. So one guy is very lazy like you, assume, right? But happened to be married. Why will not leave? Na? So she said, today Harikatha Puranam, it is happening in our village, go and listen. Then he ate fully, but he can't say anything to wife, no, because wife. Then he went to that and everybody is coming like this. There is a place, open place, everybody is sitting on ground at that time. So everybody is coming. This guy said, the Pravakta, what we say, this guy who is giving this thing. So Vastunara Randi is what he said. So you are coming, na? Please come. Then everybody was sitting. Did this way, that way, and all he started. This guy fully ate and slept. Right, he slept. And meanwhile, over 1.5 hours, 2 hours over, everybody, said, his friend is sitting, Arey, wake up. Nah, this is over. The pravachanam is over. So then, that guy, so he woke up. So then he said, like, Veltunara Bhaktulara, Vellandi, Vellandi. These three things he learned. When you learn certain things, there are two things. One is effective learning, one is successful learning. Communication also, these two ways. Successful communication, effective communication. Successful communication is one where if I teach something, if it is reaching to you, it is called successful communication. But going home, you are thinking what it is, what happened, then that is called effective communication. So this Pravakta, this guy is intelligent only, so he went home and slept. So on that day, thieves entered in his home. Right. So he slept, but he was, remembering those words such in a way he's chanting in his sleep. He said like, Vastuna Bhaktulara Randi, Randi, Randi. So you are coming now, please come. Then these thieves thought this guy is not yet slept. So we just sit beside and then we rob his home, is what they thought. They were sitting beside a pillar. Kuchuntu Nara Bhaktulara, Kuchundi is what he said. So then the thieves they thought, God, this guy has seen us, so they are going like anything, they are running like anything. Then he said, Veltunara Bhaktulara, Vellandi, Vellandi, Vellandi. So, dear friends, you are by force you are here, or by chance or choice you are here, Bhaktulara. If you learn something, it will helpful for your life. If Mama is very strong, already fixed, Mama's Betty, no need of BC. 1 acre nearer by this K University I have, no Bachelor of Computer Application. Right? But anyhow, so you are in the process, so you are a student, so you are learning something, should not be any force. If you are really feeling bored, you stop me at any moment. We will have a cup of tea and then we'll continue. But in the end, we should have certain goals. So I joined in NIT Warangal in 2006. I was not knowing what is research at all. But I started working with my just first year students. In 2007, we came up with a paper and one of my students presented in Malaysia, international conference in Malaysia. You just see my profile, then you can access all my research papers. So a first year student, just a first year student, presented a paper, research paper in international conferences. Okay, so that happened in 2007. Why not now? If 5 years, if you listen to me, then definitely if you are good enough at programming, you may get a chance to work with NIT Warangal. And if you work with NIT Warangal, one project with me if you do, the recommendation letter which we write, it makes a lot of difference. Okay? Right, so that opportunity comes in, then you have to utilize. Yesterday also, Mettu Srinivas, he came here, right? You were the audience? Yes? And he is a PhD from IIT Hyderabad, postdoc from Japan. Then you can have an opportunity of working in foreign too. Right? So, when opportunity comes in, you have to utilize. So, this is a research paper, prediction of breast cancer using artificial neural network. So, the artificial neural network which you are going to study today, are used in biomedical applications. For what? Breast cancer prediction. Right. So now you see the paper, and now you try to see this paper, and after completion of my lecture, you try to see whether you understand this or not. Okay. Some of the terms, whether you can understand or not. So you can implement it. Okay. All right. So this is like that. There are so many papers in real engineering or real life applications. So with that, we'll start up. So I'll be going slowly, and the same thing which I am teaching, the things I'll try to give you with Python coding. Okay. So I'll show you that. I need internet. Meanwhile, you can arrange internet so that I can access Google Colab. Okay. Okay. So we study artificial neural network. You heard this neural network? Where you find neurons? Inside of your brain. Right. So biological neuron you studied, and similar. Is a human is intelligent? Are you intelligent? Are we human? Correct, na? So we are intelligent only? Huh? Right. So in that case, the same intelligence can be mimicked artificially by using certain things, which we call it as ANN, artificial neural network. Okay? Alright? So now we will try, and this artificial neural network is used for computer vision applications to classify. Here you have two images. Okay, here you have two images, and this neural network which you design artificially should recognize which animal it is. So it can be used for classification. Neural networks are used for classification. Example, you write 0 to 9 letters. So I write 2, my friend will write 2 like this, somebody will write 2 like this. Any case, the device should recognize it as a 2. Right? So, digit classification we require. Whenever you are writing, digits is what you need to recognize. Digits are how many in decimal number system? 0 to 9. So, total digits can be classified into 10 classes. 0th class, first, second class, means 2, number 2, number 3, so on up to number 9. So, why neural networks are used? Neural networks are used for classification purpose. A person is having breast cancer or not. Right. When you take a CT scan, then the machine should say he is having breast cancer or not. This is one application of ANN. So how it is designed, we'll try to see now. So there are 10 power 11 neurons are there in the brain. How many neurons? 10 power 11 neurons. So one neuron is what we try to say. See, this is what the neural connection, right? And information will be stored here. Right. So now let us take a kid. He's 3 years old. Then you start teaching number system, counting, beta count. How do you start? 1, 2, beta number system is used for counting unknown quantity. So when you have 5 pens, you start counting like 1, 2, 3, 4, 5. The moment you teach one iteration, the guy will learn no. What you do? Again you teach. Beta 1, 2, 3, 4, 5. Yes or no? Second iteration. Then you ask, beta how many? Then he may say 2. But actually is how many? 3. But predicted is how many? 2. Error is there. So then what we do? We again train so that our neurons will get updated. So the information updation happens here. Whenever we see our friend, childhood friend, we may not recognize, but all of a sudden, array, he is my friend. Array, 4th class, Ramesh, right? Is what you say. That's what. Neuron getting fired. Information is retrieved from the neuron. Yes or no? So, we'll try to see one neuron, and if you understand biological neuron, then artificial neuron is work very easily is what you can design. Okay? Right? So, now, can you identify some parts? Biological neuron? Cross section, we call. Right? What it is? Can you identify something? Huh? What are these? These are dendrites. Correct, good. Dendrites. What is this? Soma or cell body. Okay. So the parts, these are dendrites. And the information is carried by a part called axon. Axon. Okay. Now these dendrites, connected to other neuron. The dendrites are connected to other neuron. The connecting part is what we call it as synapse. Bhaktulara, whatever you are learning today, by going home you have to chant. Otherwise, mama should be strong. Any 2 things are there. అమ్మాయిలు మామ స్ట్రాంగ్ ఉంటే సంపాదించి పెడితే నష్టమే లేదు రైట్ ఐ విల్ కమ్ టు గై వెరీ ఈజీలీ 18 years at Vasavi, 1 year at Vasavi, 18 years at NIT Warangal, 1 year at Farah. How many years? Total 19-20 years of experience. Each semester at least 2 batches. 2 into 60, 120. 120, 120, 240. 240 into 20. Those are my students I did with. Bida akadi kuda vasta. Right? Okay, done. So, dendrites, cell body, axon. Right, this is one neuron. How many neurons are there like that? 10 power 11 neurons. So they are connected, right? Okay. Now, so draw this now. This is very, very important because the deep neural networks which you call, if you know this, you can understand it very easily. So, in an artificial neural network, you have to understand very, very clearly. So, draw the structure. Okay, biological neuron, and we need to design artificial neural network also. Okay. Drawing cell body. So, Vastunara Bhaktulara, one word na. Valtunara Bhaktulara. So, cell body, axon, okay, dendrites, synapse. Yeah. You are alone with your mobile? No. So, now you tell me, if this is a biological neuron, no? A chemical reaction takes place. Okay, a chemical reaction takes place here. Like whenever you see your friend, array, he's Ramesh, you know, neuron gets fired is what we say, information is retrieved. So neuron is getting fired is what we say, bida tondra vadu. Right. Can you guess what is my salary? Check it out. Right. So if you want to be somewhere, so I visited up to now almost 9 countries. Almost 9 countries. We Indians, do lots of work, but Chinese also, they are very hard worker than us. I visited Australia, and most of the professors are from Chinese background. They will be getting around almost like 110 US dollars per year, per annum. Can you imagine what would be the salary? Into 80 per month, 1 crore plus, you get right? So any one of you can be in that kind. Target your education outside, okay? Himad Sagar itself, if you stop yourself, Hydra will come, you will be in buffer zone. Alright, okay, chalo. So now drawn, so now this is, now these dendrites collect information which is coming from the other neuron, and this information is a chemical, is what we try to get it in cell body. And so this is what it look like, dendrites, axon, this is axon terminal, and the connection of the axon terminal we call it as synapse. Synapse. So our information in the brain stored in synapse. Synapse, right? So a biological neuron look like this, exact biological neuron. So this is what your soma or cell body, these are the dendrites, and this is the axon of some other neuron. And where it is getting connected, we call it as synapse. And when all these chemicals comes to the soma, a chemical reaction takes place there, and if the neuron, if it is getting fired, like your temperature, so temperature actions, two actions. When two chemicals are getting added, temperature may be generated or temperature may be absorbed. We call these two actions what? Exothermic, endothermic. Similar way, neuron may fire or may be fired or may not be fired. Okay? So all these chemicals which get through the other dendrites comes to this soma, and when it is more than 0.7 volts, a potential difference of this chemical reaction produces a potential difference. When it is more than 0.7 volts, then neuron is said to be fired. Then we say like, and this neuron is what getting fired means. It is a non-linear action. Which action it is? Non-linear action. There is no non-linear device in the nature. Try to take resistor, inductor, capacitor, transistor, by which you implement your real devices. There is no non-linear thing. So when we use neural networks, when non-linearity has to be approximated, we use neural networks. What I said first, neural networks are used for classification. Second thing, when there is approximation of non-linearity, then we use neural networks. Example, where you see non-linearity. Have you seen stock market data? How the stock market data look like? BSE index? It is highly non-linear, right? Is that no? Now if you can predict what would be the dollar rate tomorrow by using neural network, which can approximate non-linearity. By sitting itself, you earn money like anything. So for stock market prediction also we can use neural network. What would be the dollar rate tomorrow, after a week, after 1 month? So one such application is, approximation of nonlinearity. Example, your stock market data is highly nonlinear. So when it is highly nonlinear, to approximate that nonlinearity, we use neural networks, right? So why? Because the firing of the neuron is a nonlinear action. Can you tell me what are the nonlinearities you know? Any nonlinear function you know? F of x is equal to, your BCNR, f of x is equal to 2x plus 3, linear or non-linear? 2x plus 3, straight line, na? F of x is equal to x square, non-linear, yes or no? Right. So sine of f of x is sine x, non-linear function, right? Cos x, tan h, these are all non-linear functions. Great. And why I am telling, because we should bring that. So you have to mimic similar to biological neuron. Then we will be using that as activation function. This non-linearity which we have to bring in reality is activation function. Okay. So now let us start mimicking these biological neurons. So what are the inputs? Dendrites. So that these dendrites are represented with input nodes in neural network, artificial neural network. The dendrites, similar to dendrites work is what? Collect information. So these are dendrites. Right. This is soma. What is the action of, what is soma? What happens in soma? All the chemicals which are collected through these dendrites getting addition. So a mathematical task will happen here, which is addition. Okay, which is addition. And here you have, this is a synopsis. And as an example I told, like the boy is learning and updating, the weights are getting updated. So the synopsis equivalent is weight. Right. See, biological neuron equivalent artificial neuron. So what we are doing? We are creating artificial neural network. Okay. So we are creating artificial neural network from biological neuron, assuming human beings are intelligent. So this intelligence can be borrowed from a human, right, as in the form of neural network. Is this all right now? So input, which is of dendrites, synapse, which are of weights, then this is what neuron, which is of cell body, and when the neuron is getting fired, it is a non-linear action. So we replicate that non-linear action with one thing called activation function. How many words we are learning now? Dendrites, axon. So this is axon equivalent is what we are getting output. Right. Right. So when you try to figure it out, x1, right? x1, x2, x3 are inputs. w1, w2, w3 are weights. Right. Now what do you get here? What happens in cell body? Sum. So what you get here? x1 w1 plus x2 w2 plus x3 w3 is what you get it here, right? This we call it as y in. y in, y out, the output of this neuron is what called y out. This y out is function of y in. What is that function? Activation function I told you, na, non-linearity. So once non-linearity which I am bringing here is a sigmoid function. Friends, I am telling you, this is very, very important and you have to know this and implement in Python. So a library which supports this is Keras. Okay, so everything which you are learning, you know, it should be there. So now here, if you try to see this y out is what we are calling. So y out is equal to f of y in. So what is y in? Y in is x1 w1 plus x2 w2 plus x3 w3. Now this function can be 1 by 1 plus e power minus x or y in, right? So this will go through a activation function. That function I am trying to take it as sigmoid function. Sigmoid activation function. Do you know how the sigmoid look like? Right, sigmoid look like this, which is a nonlinear. So the nonlinear function which we are trying to take is a, here we are trying to take sigmoid function. Okay. Now what is y out here in this case? Y out is 1 by 1 plus e power minus x1 w1 plus x2 w2 plus x3 w3. This is what my y out. This is one neuron. How many neurons are there such kind? 10 power 11 neurons. So when I bring more than 2, non-linearities is what we try to get it, right? So here when you try to see, so this is what the complete neuron. So I is equal to 1 to 3 xi wi generalization. Okay, xi wi generalization, and output is what? The function of y in is. So that is what we try to get it. This is what one neuron, and we call it as perceptron. There is one more name given for this is perceptron. Right? Up to this point is clear now? We will be doing learning by doing. I'll teach and we'll be solving a problem. Okay? And after that we'll try to see that in coding, Python. Alright? Okay. Now, we use one more term called bias. We use one more term called bias. This bias is getting added up here. One more constant we will add up in the neuron, which is called bias. So when you try to take it in mathematical thing, then this is equivalent of bias. Constant. Why? What is the significance of this bias? Now let us try to understand. Now this is what your expression na? When x1, w1, w2, w3 are 0, w1, w2, w3 are 0, because in the beginning child is not having any knowledge in the neuron, na? You are training, right? Updating weights, right? So initially we can assume the weight 0. When you assume this weights 0, w1, w2, w3 becomes 0. When it becomes 0, what is the function output? This is 0. So 1 by 1 plus e power minus 0. Any to the power 0 is what? 1. So 1 by 1 plus 1. 1 by 2, which is of what? 0.5. 0.5. Correct? Now, if this W1, W2, W3 infinity, what do you get? Plus infinity. they are plus infinity, what do you get? It goes towards FLO. 1 by 1 plus e power minus infinity. So minus infinity means 1 by 1 plus 1 by infinity. So 1 by infinity is what? 0. Right, 1 by infinity is 0. So 1 by 1 plus 0. What do you get? 1. So when it extends towards infinity, it reaches 1. Yes or no? And when it is minus infinity, it reaches towards, it reaches towards here minus 1. So always the function goes through 0.5. Any value you try to take, it goes through 0.5. But the moment I add a bias, I can shift this nonlinear function, right? That's what the physical meaning of the bias. When neuron is not getting fired, we add a constant to it to get fired. The term is called bias in biological term. And in mathematical term, it is a constant which we are getting added up. Clear up? Right. So this neuron, now this is what the whole thing which you study, which you learn up to now. So what slowly we are moving. Y of n is equal to function of, that function can be sigmoid, the function can be tangent, the function can be any nonlinear activity. Okay, right. So Wj of n, Xj of n plus B of n. So this is what a artificial neuron look like. Up to this point is clear? No questions? Is it alright? Up to this point is clear now? Simple mathematics and which can be written in the form of Keras library. How to import Keras library and then how to bring these functions, I will tell you. Okay? Right. Now, similarly, how many neurons are there? I said 10 power 11. So these are input nodes and these are hidden nodes. So this is first hidden node. How many number of neurons? 1, 2, 3, so on. And one more hidden node and then output layer. Okay? Right. So this is for classification. So this is multi-perceptron is what we call MLP. Okay? Alright. So now the same thing, neural network, there are two things happens. One is training, one is testing. What do you mean by training and testing? Kids example, when you try to take beta learn 1, 2, 3, 4, 5 is what called training. So when you give input, you get output. And this output, what you do, you compare with the targeted output. In this example of training a kid, who will be the teacher? Mother or father? So you compare your actual output with the desired output, right? So here, this is 3, but kid said 2. So what is desired? 3, but actual output what he got is 2. So true minus desired is what? Error. So when error is there, then this error we back propagate and we update weight such that this error can become 0. If error is becoming 0 means what? Whatever you gave input, you are getting output, and then the desired output is what you got. So your neuron got trained. This is what the physical meaning is. This point is clear? And we use an algorithm to update the weights of the neural network, which is called backpropagation algorithm. Backpropagation algorithm. Up to this point is clear? So now let us try to take this example. Draw this now. This is very, very important. Draw it in the notebook. You follow me, I will be explaining, you will be drawing. You will not get sleep. Otherwise, you will get sleep. Otherwise, I need to say, stand up, sit down. Stand up, sit down. Right? Alright. Now, see the board and follow me. Input is x1. So here this is input node. It is called input node x1. One more node you can draw, which we can call it as what? x2. and so on to address any neuron in the input layer. I am calling that as ith neuron, xi. And how many neurons are there in the input? N. So what is the last one? Xn. Right, Xn. Then this is hidden node, hidden layer. In hidden layer, how many neurons are there? Z1, Z2, so on up to address some neuron in the hidden layer. I am calling it as jth neuron. What is the, for addressing here, what is the neuron I said? I. Xi. Here, Zj. And how many neurons are there in the hidden layer? Here, P. N here, P here. Okay? And now, fully connected layer means each node is connected with each neuron. This is connected with first, this is connected with jth neuron, this is connected with pth neuron. So fully connected layer. The weight between input and hidden is given with a name V. V11 means what? Weight connecting between first node in input layer to first neuron in the hidden layer, which is called V11. Now let us take, I have Z2 here. What is the weight between 1 and Z2? V1 2. V1 2. So to represent any weight between ith neuron in the input to the jth neuron in the hidden, what I can name it? Vij. That's all. Vij. Now a bias is added here, and the bias is called VOP. VO1 here, VOJ here, VOP here. We add bias, na? That's what I said, right? Each neuron we add a bias, which is a constant, right? Clear, huh? Yeah. Is this clear? What? Break. I'm not getting it. Represent. Had your breakfast? No, I didn't. Yeah. Chai biscuit. ఓకే, ముందే చెప్పిన మామ గట్టిగా సంపాదించి ఉంటే ఏ విఐజీలు అవసరం లేదు, లేకపోతే జీవితం సంకనాకి. ఏదేదో మూవీలో అంటాడు చూడండి, ఏదో సూపర్ మూవీలో బ్రహ్మానందం ఉంటాడు, అలీగాడు డ్రాయింగ్ చేస్తూ ఉంటాడు. ఏమంటే మిమ్మల్ని ఎప్పుడు కలవచ్చు అని అడుగుతాడు. చెప్తాడాయన, నీ జీవితం సగం సంకనాకి, నువ్వు లాస్ట్ స్టేజ్లో ఉన్నప్పుడు నన్ను కలుస్తూ ఉంటాడు. అక్కడ దాకా పోనీయకండి మీ చేతి. ఇందులో ఏముంది, టఫ్ ఏముంది? ఎవ్రీథింగ్ ఈజ్ ఫైన్. ఓన్లీ థింగ్ ఈజ్ మనసు దూరం వెళ్తూ ఉంటే ఇమ్మీడియట్ బ్యాక్ తీసుకురండి. అరే ఈరోజు ఏదైనా నేర్చుకుంటే నాకు పనికి వస్తుంది, నాకు జాబ్ వస్తుంది. ఇట్ విల్ ఫెచ్ యూ జాబ్. ఐఎమ్ టెలింగ్ యూ గైస్. ఆ కాన్ఫిడెన్స్ లెవెల్ మీకు ఇస్తాను. నేను ఇంత లో లెవెల్కి వచ్చి చెప్పాల్సిన అవసరం లేదు. బీసీ అనేసరికి కంప్లీట్ దిగింది. రైట్? ఓకే, రైట్. నా what would be Z1 in? Right expression for Z1 in? What was here Y1 in? Y in? నిద్ర నాకు రాయండి. Each neuron has to be connected to each neuron. That is called fully connected. So what is Z1 in? చెప్పండి. x1 into v11 plus x1 into v1j plus so on up to x1 into v1 p. Yes or no? That is what? Z1 in. What is Z1 out? If I assume the nonlinear function here a sigmoid function, what is Z1 out? 1 by 1 plus e power minus Z1 in. Up to this point is clear, na? So can you write the expression for Zj out? What is Zj out? Zj out is 1 by 1 plus e bar minus Zj in. So what is Zj in? x1 v1 j plus x2 v2 j plus so on up to xi vi j plus xn vn j. That is what? Correct, na? Right. So if you try to write this, then you will be getting this output of this. Similarly, what would be y1 in? See here, y1, y2, so on up to yk. To address here, ith neuron, jth neuron, kth neuron. And how many neurons are here? M. Right, M. So can we write yk out? Yk out is 1 by 1 plus e bar minus yk in. What is yk in? Z1, the weight between here is W, here V, here W. So W, J, K, jth neuron to kth neuron. W, J, K. Correct, na? So Z1, W1, K plus Z2, if there is Z2, Z2, W2, K plus so on up to W, J, K. Yes or no? Right. This is what the generalized expression. Okay. So Z in J is VOJ. Bias is added na. VOJ plus summation I is equal to 1 to n xi vij. See, one day in a hard sun, if you work, people are giving for Bihar and Chhattisgarh or Orissa laborers 500 rupees. 500 rupees per day. You cannot work 6-7 days in a week. 4 days he will work and 3 days he sleep. That much hard. How much he is getting? 500 rupees. But if your package is 1 lakh per day, how much you are getting? Almost 3,000. So how many hours you work? 8 hours you work. You work with brain. That's why you will be paid more. You want to work. See, these days, never beating field, you know. You will get employment on any day. Where? This water lifting, everybody is using, waters, right? And the water, one bubble, 20 kg per day, 100 bubbles you lift. That day you come to know how to study or not. Evergreen field, that one. And a rod is bended by a labor on 10th floor on a hot sun. Imagine, he is given 1,000 rupees. You are calling, sitting in AC and then calling Zj out. That's what you have to learn, that's all. Okay, hold concentration. Okay, so then y in k is wok plus summation j is equal to 1 to p w. Is it clear or I have to repeat? It's clear, na? See, here when you try to see z in j is summation I is equal to 1 to n xi vij plus bias. Okay. So shall we do it learning by doing kind of thing? Shall we take an example? And for this we have to write a Python code, artificial neural network. Yeah, try to take this neural network. So what is the neural network? How many input neurons it has? 2. X1, write down, right? X1, X2. Hidden H1, H2. Output Y1, Y2. And this is connected with this W1, this is connected with this W2, this is connected with this W3, this is connected with this W4, weights. And H1 is connected to Y1, W5, this W7, W6, W8. So Y1, Y2. So what is the problem here? Drawn? Specific. And the same thing I'll try to give you an example for you also, where you can design a neural network. Iris dataset classification. I'll relate this to Iris dataset classification. I'll try to show you the coding also. Fine? Huh? Same thing, what we are learning. So now the problem is when x1 is 0.05 and x2 0.10, then w1 and all they are given some random values. Okay, initially you can assume it's 0, and then here y1, the output you should get here 0.01 when input is 0.05. That is the problem. When input is 0.05, then you should get the output 0.01. And when in the input is 0.10, then here you have to get output 0.99. That is the problem. So how to update the weights of W1, W2, W3, W4, W5, W6, W7, W8 so that when input is 0.05 and 0.10, you get your output 0.01 and 0.99. Is the problem is understood? Is the problem is understood now? Right. So now when you give input, you get output. This is called feed forward propagation. Feed forward propagation. So now you can calculate feed forward propagation. Yes or no? So now what is H1 in? What is H1 in? X1 W1 plus X2 W2 plus B bias is what? H1 in. What is H1 out? 1 by 1 plus e power minus H1 in. That is what? You get H1 out. What is Y1 in? Similarly, you will get H2 out here. So H1 out multiplied with W5 plus H2 out multiplied with W6 plus bias B2 is what? Y1 in. What is Y1 out? 1 by 1 plus e power minus Y1 in. So that is what you can compute now. Because values are given. You have to write a Python code for this actually. If you understand very clearly. Then the first step you have to import libraries. Why we use Python? Because inbuilt functions with Python. Then we import keras. I'll try to show you that. Okay. Then this is what H1 in. Then out H1 is 1 by 1 plus e power minus H1, which is a 0.5932. Similarly, you can calculate H2 out or out H2. Yes or no? So the out H2 is what it is calculated here. Is it alright? Take it as an example. By going home, you do it. Implement in Python. You send me the report. I'll take you as my internship student. Very easy. Right. This course I am teaching to MTech students. Right. So similarly you can calculate out H2 and similarly you can calculate Y1 in. So what is Y1 in? Out H1 W5 plus out H2 W6 plus B2. So now you have out H1 W5. So W5 initial is given some random values. Correct? Right? So then out Y1 is 1 by 1 plus. So this is what 0.75. But what was the problem? What was the problem? What is the output of Y1 you got? 0.7. But what is expected? What is expected? 0.01. So what you should do now? You need to update the weights such that it will become 0.01. Is the problem is understood now? This we do it with the help of an algorithm called gradient descent algorithm. Up to this point is clear. Feed forward propagation is clear. And the same thing if you learn, then you can understand convolution neural network, which is in the output layer is ANN. Flat layer is what we call flatten. That flattened layer is ANN. Up to this point is clear? Right. I will give you the algorithm. You can think of during your breaks and then you can come back so that we can try to implement this algorithm very simply. I will give like a story. How we can get here 0.01, we got 0.75. How it is possible? Let us try to take example of dice. When you throw a die, what is the sample space you get? Die has how many faces? 6. So any value you get between 1 to 6. So your sample space is 1 to 6. Any value between 1 to 6. Done. Assume I have a 100 phase die. Example, assume. What is their assumption? So what is my sample space? 1 to 100. I have thrown the die and I kept myself. I got a value 40. Then I asked my friend, "Are guess ra?" Right. I asked my friend, guess how much it is. So he can guess any value above 40, below 40, any value 1 to 100. Correct? Na? So randomly, let us take here, he guessed a value 80. He guessed a value 80. Then I said, wrong. What was the true? Desired? 40. What is actual? 80. True minus, desired minus true? Error. So error is there, na? 40 minus 80, 40 error is there. Then I told, I'll give you chocolate, ra? You guess one more time. Then he can guess above 80 by taking a current value reference. Above 80, below 80. Only two choices. Correct? Then he guessed, let us take 70. Then I said, you are right direction. Okay, then I said, you are in right direction. So, then he said, array, it is wrong, but it is in right direction, is what I gave information. So, I'll give you 50 rupees chocolate now, you guess. It's what I said. So, when he guess in third trial, he will go above 70 or below 70. Because I said you are in right direction. That is done by using gradient, slope. Okay, this is given by gradient. Then I said, you are coming close. Guess one more time. So then from 70 he came to 60, and from 60 he came to 50. So what is the step length he is taking? 10. That is called step length. Right. And then, one more choice I'll give you, means he can guess which is 40. So he arrived or not? This is what is written in the form of an algorithm called backpropagation. That's all. What was the algorithm? Backpropagation, which is W of k plus 1, the new weight is equal to, when you are guessing the new weight, what you are considering? Old weight. Your old value you are considering, right? 80 or 70. So old weight minus step length, eta. How much was the step length? 10. If step length is large, quicker is the convergence. Yes or no? If step length is 5, let us take he has taken 5, you would have taken more number of iterations. Okay. So eta into dou E by dou W. This is what called back propagation algorithm. Eta is what? Step length. You are moving in right direction is what information given by your friend who made you to come towards, which is what? Gradient. Right. So now how it is? If I have an error function like this, then dou E by dou W when I try to do, the slope is negative. Negative of negative is positive. I am in right direction. And if I get the slope, if it is positive, if I get negative means he is going above it. Meaning is that. Is this understood? So this is called back propagation. How to use this back propagation is what I will try to take up after the break. The problem is what? This should become 0.1. It should become 0.1 means you have to update W5. You need to update W1, W2, W3 using back propagation. That is what we try to see. And same thing I will try to show you for real-time application for MNIST data set. So I will be using neural networks for a digit classification. I will show you the code after the break. So if you have any question you can ask me, otherwise you can take break. So the choice is with you. Mama is strong, otherwise come. I'll show you with coding.
Yes, sir.
నేర్పిదిరా వాడు చదువుతాడు ఫోటోగ్రఫీ నేర్పియా ఏ శివ ఒక నిమిషం మా ఛానల్లో ఫోన్
check, check, hello, hello, check, hello, hello, check, check, hello, hello, check, check, hello, hello, check, hello, hello, check, check. Hello? Yeah. Ready? Huh? Which one? Hurry! Huh? How much? E has value, no? That only you can substitute, right? What is E value? Point? What was E value? Point? E value E ki standard value undi kada? Statement no. ln base 2. ln base E, natural logarithm. Alright. Okay, so let us go ahead. Now it will be little bit difficult. You have to pay concentration because you have to understand what is the mathematics of this. Concentration. Yeah, okay. Yeah. Yeah. So now let us go ahead. So this is in output layer, how many neurons are there? 2. So we compare out y1 minus t1, one error. Out y2 minus t2, one error. So what is total error? What is the total error? E1 plus E2. But error can be positive or negative. Yes or no? So to make it, what we do is, we try to take square. I'll explain this concept. Babu, ivanni kuda interviews lo adugutaru. AI anagane first vachedi neural network. Artificial intelligence anagane first vachedi neural network, NN. Okay, so this is that much important. Okay, so now let us try to take, you have a value like this, and now you are going to estimate. So actually is this, predicted is this. Then predicted minus actual is what the error, which is positive. But here, actual is this, predicted is this. This is what E2. If I want to bring everything into account, then E1 plus E2 plus E3 and so on. This would be E3. This would be E4. This is what my E total error. Now, let us try to take, this is E1 is plus 4, E2 is minus 4. When I add, effect of this error is getting cancelled. So that sample effect will not come into picture. But each and everything I want to bring in into the consideration. So what I do to take the effect of each sample on the model, then what I do is I'll try to take E1 square and I'll try to take E2 square. E1 is 4 square, E2 minus 4 square, so plus 4. So I am bringing that sample effect into consideration or not. So we do square. So the cost function, when we try to take, then this one is what we try to square it, error square. And the moment I am doing square, then I am taking half is what? Equal weightage to each error. Half plus half, and now it is becoming 1. So half E1 square plus half E2 square. So this is what my total error. Is this fine? Up to this point is clear? Because we calculated out y1, t1 is with us. Out y2, t2 is with us. So then we calculate, we get total error. Now is this clear now? So this error I need to back propagate. This error I need to back propagate and we need to update W5. Yes or no? Right? So then we will be using this back propagation algorithm. How that is, now let us try to see. Now, what is W5 new according to this algorithm? What will be W5 new? W5 new is W5 old minus what? Learning rate parameter. What is learning rate parameter? Step length. Step length into dou E total by. Now, what is the contribution of W5 on total error? So, how I can update new? What is the effect of W5 on total error? When W5 changes, error changes or not? Yes or no? W5 changes, error changes. So, dou E total by dou W5. Up to this point is clear? Now, how to compute dou E total by dou W5? 10 rupees chocolate dairy milk I will give if you tell this. What is E total expression? This one, na? Now what I need to do, I need to update using this, right? When I need to do it, right, when I need to do it, then W5 new is old I have already value. Then I need to compute this term, learning rate parameter, that is my wish. Smaller the value, more iteration. Higher the value, lesser iteration, it will converge. Okay. Now, so can I differentiate? Now, when I differentiate this dou E total by dou W5, is there any W5 term here? Can I differentiate this E total with W5? No. Right. Correct, na? Follow with me, hold concentration, very, very important, and you will not get this in any book. Right. So, now dou E total by dou W5 is what I need to do. So, dou E total by dou W5 is what I need. But is there any W5 term directly? No. But what is out Y1? What is out Y1? 1 by 1 plus e power minus Y1 in. Right. So, but what is Y1 in? What is y1 in? So now tell me, out h1 into w5 plus out h2 into w6 plus b2. So w5 term is here. So then to get differentiation, what should I do? I need to use chain rule. Yes or no? See, I want dou E total by, నేను మ్యాథమెటిక్స్ దిగితే మీరందరూ పారిపోతారు. Dou E total by dou W5. This I can write it as, this E total is having out, the E total is having which term? Out y1. So then I write dou E total by dou out y1, dou out y1 by dou y1 in, dou y1 in by dou w5. Can I write like this? Can I write this chain rule? It is not direct function, but it is indirect function. So dou E total by dou out y1, dou out y1 by dou y1 in, dou y1 in by dou w5. Yes or no? Now when E total is this, can't I do dou E total by dou out y1? If I want to compute this, dou E total by dou out y1. What is dou E total by dou out y1? X to the power n, d by dx of x to the power n. What? N into x to the power n minus 1. Similar, na? Yes or no? So now you differentiate this with respect to out y1. What do you get? Of x to the power n, 2n, n into x to the power n minus 1. X is what? T1 minus out y1 into 2 minus 1, n minus 1, na? Yes or no? Right. Then d by d out y1 of T1 minus out y1. T1 is a constant, 0. So dou out y1 by dou out y1, what I get here? Minus 1. Yes or no? So I will be getting minus 1. So 2 will get cancelled. Minus of T1 minus out y1 is what? Dou E total by dou out y1. Is it clear? ఎండలో పనిచేస్తే 500 ఇస్తారు, ఏసీలో కూర్చొని ఆలోచిస్తే ప్యాకేజ్ వస్తుంది. LPA, lakhs per annum. 500 rupees into 20 days, 10,000 is a package outside. So you want 10,000 or hold concentration and then sit in the class and work out this mathematics. Is this understood now? Correct now? So first term, see, if I want this, then I need to compute this. If I compute this, then I need to compute this. Dou out y1 by dou out y1. So what is y1 in? What is out y1? What is out y1? 1 by 1 plus e power minus y1 in. So I need to do what? Dou out y1 by dou y1 in. Y1 is here. Yesterday my student told, like, he was executing a program. It took around, when TPUs are used in k-means clustering, to say how many clusters, how many centroids you need, took around 5 hours. So when computations, when program is running more, means it is doing computations inside. So it's computation inside. For this term you need to compute this. Yeah, so this I will give you with the help of one formula. Yeah, f of x is equal to 1 by 1 plus e power minus x. Dou f of x by dou x is equal to f of x into 1 minus f of x. This is well proven in mathematics. Yes or no? So now, is it in that form? Out y1, dou out y1 by dou y1 in, dou f of x by dou x. How can I write? F of x into 1 minus f of x. So how can I write here? What is f of x here? What is f of x here? This is x you can consider. This is f of x you consider. So here this formula is f of x minus 1 minus f of x into 1 minus f of x. Then how can you write? Sir told he will give internship at NIT Warangal, means that much easier. Right. So what you can write? You can write this as f of x. So out y1, 1 minus out y1, f of x into 1 minus f of x. Ardhamainda? Is this clear? If teacher teaches, it takes 1 hour, but when friend explains, it will be 10 minutes, because he explains in Telugu, no? So sometimes I am using Telugu. Is this understood now? So then I can calculate this. Then dou y1 in by dou w5. What is y1 in? What is y1 in? Out h1 into w5, out h2 w6 plus v2. Dou y1 in y, what? Dou w5. What do you get? What do you get? W5. Yes or no? See here, the same thing I am trying to show you here. Dou E total by dou out y1, which is minus of t1 minus out y1. So this is what I computed the first. This is clear? This is clear? Okay. This point is clear? Then next is the next one. Out y1 is this one. Dou out y1 by dou y1 in is out y1 into 1 minus out y1. This is also I calculated. Dou y1 by dou w5 is what? This you are differentiating with respect to w5. When you differentiate this with respect to w5, what do you get? Out h1. When you differentiate this with respect to w5, you get what? Out h1. So this is what the out h1 term. Now these three you multiply, right? These three you multiply, you get dou E total by dou w5. And what is the formula? And learning rate parameter, consider 0.05. Right. So then this is what w5. We computed how many weights? Similarly, you can do w6, w7, w8. Clear? So you compute this and then get w6, w5, w8. Clear? Alright. Now we see what we are doing. We are back propagating the error and then we are updating the weights. One layer we have done. Similarly, we need to update the second layer, this one, right? So W1 new is what? W1 new is W1 old minus learning rate parameter into dou E total by dou W1. If anyone does this, then I'll give you internship right now. You can stay in 1 month in NIT Warangal. Right. What was the question asked? You need to update now what? W5 done. Next one, what you need to do? You need to update W1. So write down W1 new is equal to what? W1 new is equal to W1 old minus dou E total by dou W1. Yes or no? Right. Now if you tell me how to calculate dou E total by dou W1, right now I will give you appointment. E total is what? Half T1 minus out Y1 whole square plus half T2 minus out Y2 whole square. Can you differentiate this with respect to W1? Not direct. So earlier what you have done? You have used chain rule. Right. So here what you need to do? Similarly you can write what? Dou E total by dou out H1. Good, very good. Dou E total by dou out H1, dou out H1 by dou H1 in, dou H1 in by dou W1. Correct now? See. Similarly, what we have done, very simple, we have to focus, that's all. Okay, so now, see, W1 new, W1 old minus learning rate parameter into dou E total by dou W1. Correct, na? So, how can we write dou E total by dou W1 is equal to dou E total by dou out H1, dou out H1 by dou H1 in, then dou H1 in by dou W1. Chain rule. Right? What is H1 in? What is H1 in? X1 W1, X2 W2 plus B2. Sorry, B1. Now, dou H1 by, what is the last term? Dou H1 by dou W1. So, what is that? X1. So, last term we computed. Right. What is out H1? 1 by e power minus H1 in. So if I use that f dash of x, f of x is 1 by 1 plus e power minus x. F dash of x is equal to what? What? Dou out H1 by dou H1 in is out H1 into 1 minus out h1, f of x into 1 minus f of x, out h1. Second term also we computed because we have out h1. This term also we computed, but problem is with what? Dou E total by dou out h1 in, but dou out h1, E total no out h1. Then what you do? Here is the challenge. Internship opportunity. This term you cannot compute. You can compute this, but you need this to substitute here. Dou E total by dou out h1. But E total is T1 of T1 minus out y1 plus of T2 minus out y1. There is no h1. You cannot differentiate. Then so y1 out you substitute there. Substitute and tell me. This is written in Keras library. Yeah. When you run a program, 1 hour it will take because it has to do differentiation, multiplication, and then addition, multiplication. This is what happens inside of neural networks, introduced in 1971. Why it is taking rebirth now? Because the computations can be done in online, cloud. You can use GPUs, you can access GPUs of Google or Amazon. So computation is not an issue now. Cloud computing facility available, that's why this AI took rebirth. AI is not new these days. Clear? Anybody? Missed? Yeah, I will tell you now. Again you need to write chain rule. What is the chain rule? Dou E total by dou out h1 can be written as dou E total by dou out y1, dou out y1 by dou y1 in, dou y1 in by dou out h1. One more chain rule. See, somebody got 80 lakhs, 88 lakhs package. They work with MeitY. Okay. If you develop libraries, you will be directly absorbed in NVIDIA for this. NVIDIA is the best company. So now, this term is difficult. So, dou E total by dou out h1. One more chain rule. Dou E total by dou out y1, dou out y1 by dou y1 in, dou y1 in by dou out h1. Because y1 in is having out h1 term na. This much chain rule you have. So that's why 50 rupees daily meal guide. How many differentiations? See, already 3, and then multiplication, then subtraction. So this is what the weight updation is. Okay, this is what the weight updation is. So dou E total by dou out h1, dou out h1 by dou h1 in, dou h1 in by dou w1. Right. So this is the first one. Then one more chain rule is what you write here. In the So I'll stop mathematics now. No mathematics further. Because you do it and submit me as an assignment, I can think of for this. It is only what? W1. Similarly, what you need to do? W2, W3, W4. Up to this point is clear? Something. Bhaktulara. Vastuna. Bhaktulara, randi. Something. Okay? Done? Yeah. So this is what the total is. So dou E total is dou E1, dou E2. See, this W1 contributes only E1 or E2 or both. Story pole apudike. This W1 contributes E1. This W1 contributing here. This is going here. So E2. So dou E total E1 by out H1, E2 by out H1. Up to now we did this one only. Similarly, we need to do this. Over. Because earlier W5 contributes only E1 chalta, but now W1 contributing this and this. So then you have to calculate this and this. This is what we have seen. Similarly, you can do it. Understood? This much mathematics. Fine. Shall we use it in real time now? Shall we take an example? Ready? Huh? Yeah. So you can do this and you can substitute. Right. Now we use this for classification. Neural network for classification is what I said. Right. The data set which you can work in reality, you can get it from Kaggle website. Iris dataset. If you type in Kaggle, then you get this dataset. I'll show you the dataset. Right. How many species are there? 3. This is one flower. This is one flower. This is one flower. Iris setosa. Iris versicolor, Iris virginica. So this is Iris virginica. This is Iris setosa. This is 3 flowers are there. Right. The features which are available now is, this is called petal. This is called sepal. Okay, so the total features are petal length, petal width, sepal length, sepal width. How many features? 4 features. Right? Now I'll show you the data set now. How many features? 4 features. You need to design a neural network for this. Okay, you need to design a neural network for this. So you'd go to Kaggle website and type for Iris dataset, then you get an Excel sheet like this. And Excel sheet will be having features like this. Sepal length, sepal width, petal length, petal width. Right. If it is 5.1, 3.5, 1.4, 0.2, a scientist told it is Iris setosa. Right. Then like this iris versicolor, iris virginica. Total how many data sets? 150 data set is available. Now, what is the problem? If petal length is 1.2, petal width is 2.1, sepal length is 2.3, petal length is 4.2, which flower it is? Which is not there here. A new thing which it comes in, then you need to classify which flower it is. Then you need to design neural network for this. Right? How many features? 4. How many neurons you can put it in the input layer? 4. Because one is iris setosa, iris virginica, petal length, sepal length, petal width, sepal width. 4. Hidden layer, 2 hidden layers you can decide. 10 neurons you can put it. 10 neurons you can put it. More neurons, computer will die to execute. Why? When updation happens, these many computations it has to do. Yes or no? Right. So, how many outputs? 3 classes, that's all. You design a neural network. That's all. 3. Now you need to write code for this. Now you need to do coding for this. Step number 1. Import libraries. Step number 2. Data pre-processing. Any value is missing here. What do you do? You add all these things and mean value substitute there. That is called what? Data pre-processing. Normalization you do. Right. This is called data pre-processing. Step number 2. Then design, import your neural network architecture. Then train. Then validate. Ready? Huh? So shall I do one more? Shall I do this or shall I do one more computer vision application? I'll give you one example. With code I will show you. If you do it, you will get internship in very good company actually. If you understand this and you will crack interview actually. Right. Now next example. This is called MNIST data set. MNIST data set. You will get it in Kaggle. This is there with Kerasa. MNIST data set. Somebody will write 0 like this, somebody will write 1 like this, somebody will write 2 like this, 2 like this, 2 like this, and all. Any case you need to identify it as a 2. Problem is that hand digit recognition is what is this problem is. Yeah, hand digit recognition. And for that Kaggle, a digit 8 is like this. This is a digit which is stored in Kaggle or Kaggle. Each is of 28 pixel by 28 pixel. Each image is of 28 pixel by 28 pixel. You need to design neural network now. What was the problem? Digit classification problem. How many digits are? 0, 1, up to 9. Total 10. Now, one image is looking like this. In turn, the image is looking like this. This dark means pixel value 0. And white means the pixel value, maximum pixel value 255. Okay, image processing application. Computer vision. Hey, you are writing competitive exams, you are writing your roll number. If machine is there, it should say what is your roll number. Hand digit recognition. Application is that. Understood? Now, how will be the 28 rows by 28 columns? Right, 28 rows by 28 columns. Correct, na? 0, wherever there is a white, the pixel value is varying. This is little dark. Here you can see the pixel value 43. Now, if you design neural network, how you design neural network which will classify this into 10 classes. So, how many neurons you require in the input? How many pixels are there? 784. So, how many neurons you require? 784. Input nodes. Output node? How many classes? 10 classes. So, how many nodes you require? 10. Right. Hidden, your wish. So, I designed a neural network like this. 784, 512, 256, 10. I will show you this code now. If you hold concentration. Okay? Is that neural networks understood now how it is solving problem? Our brain is mimicked and artificially we are creating neurons. Correct? If you are ready with me, I will show you the code. So 784, 512, 256, 10. Now if I have 2 neurons in the input, 2 neurons in the hidden, how many weights associated with? I have 2 input neurons, I have 2 hidden neurons in the hidden layer. How many weights associated with? 2 into 2? 4. How many weights we need to update here? 784 cross 512. Yeah. And here 512, here 256, how many weights would be? Here 256, here 10. How many weights? 2560 weights. One weight itself we died. So computer has to update how many weights? Computationally, neural networks are complex. So that's why we use convolution neural networks which reduce the computations, which I discuss in the afternoon class. Right, but shall we do the coding of this? Shall I show you? Okay, right, chal. So this is what the neural network structure is. 784, 512, 256, 10. Who told you? I myself did. You do your own and then you compute the accuracy. Okay? Chalo. What is step number 1 for this problem? Importing of libraries. Which library can be used to use neural networks? Keras. And you need to do that equation. Then NumPy, numerical calculations. If you want numerical calculations. Okay? I'll be showing the code now. import computer vision CV2. Okay, so here it is not used direct plotting, but that can be done that way also. Right. So here Keras datasets import MNIST. So in Keras also this MNIST dataset available. So from Keras datasets import MNIST, and Keras layers import dense flatten. I'll tell you this. This is what this is what importing of libraries. Now this MNIST dataset has 70,000 images. How many images?
70,000.
Each image of how much size? 28 cross 28. So we cannot use all 70,000. We cannot use all 70,000 for training purpose. So we divide that into training set and testing set. 80-20, 75-25 or 70-30. That way you can divide. Okay? So this is divided into 80-20. So 80% of 70. So here it is 60,000, 1000 is what it is divided here. Okay, you can mention that here specifically to divide in X train, Y train, X test, Y test, this MNIST load data. Now, what would be X train? X train will be having 60,000 images and test will be having 10,000 images. X train, Y train. Okay. Now, how it is stored in dataset is, if 8 I have shown you na earlier case in my slide, this is 8 na.
Yes.
So it is labeled as EIGHT. It is 8. Okay, so the data is categorical. Digit can be 2, it is written TWO2. So supervised learning means what? The data is there and it is already labeled. So Y train would be what? Labeled data. Okay, labeled data. So it is written here as 8, not EIGHT. 8. It is written here 2. It is written here 1. So output can be 8, 2, 1, 0, like that. How many values you get? Training 60,000 values. Testing how many values you get? 10,000 values you get. I want to display it and then I want to see it. That's what it is there in the coding. So connect. Here you can change runtime. You have CPU, GPU and TPU. These are the facilities given. More computation you want, then you need to pay to the Google. Okay, right. So we will do step by step. So I am importing of the libraries. Okay, and then I am splitting the data into training and testing. CPU, it takes time. 9 seconds it took. Then I am doing training and testing. And then I want to see print X train shape. So what was the shape? Training, how many images are there? 60,000. Each size is of what? 28 cross 28. So that is what? X train. And Y train 10,000. 10,000 samples are for testing. 28 cross 28. But each data is labeled 8. So 60,000 labels. Okay, right, 10,000 labels. I want I can print any value, I can plot any value x test of 25. Okay, I want to show it. 25th image is what? What is the image here? 0. So if I change it to, let us take 1000 image. Total 10,000 images are for testing. So 1000 image is what? 9. In testing and training you can plot and you can see. Up to this point is clear? So data importing and then I am just displaying it. Now what I do is, right, so just I plotted this input and then I plotted, I am displaying, so some series of images I want to see in the data set how they are. So I am writing a simple function for, okay, for some 5 images I want to display. So columns 5, right, access display. So 5 it is there as an pixel image and it is labeled as 5. Okay, only 5 images. Like that, how many images are there? 70,000. Only 5 images is what I am. Why train? There is a problem. What is the problem? One is given 5, another one is given 0, another one is given 4, another one is given 9. So then what I should do? I should do equal weight for all digits. Then I do one hot encoding. What do you mean by one hot encoding? I'll give you very simply. Hold concentration, pay attention. See, iris dataset classification we did, right? How many flowers are? Iris setosa, virginica. Yeah. So can I give 0, 1, 2? I can give. But 0 is low weight, 1 is medium weight, 2 is higher weight. This is not correct. While I am training. So then what I do, I use a digit like this. One flower I will give 100. Another flower I give 010. Another one I will give 001. All are having equal weight, only 1. Some is 1 only, but different symbols. Yes or no? This is called one hot encoding. This point is clear? This is one hot encoding. So why train has to be done one hot encoding? When you do one hot encoding, how many, what do you get? How do you represent 1? How many digits are there? How many digits are there? 10. 0, 0, 0, 0, 0, 9 zeros and 1. Right. And then that is will be 0. Then 1 will be 0, 0, 0, 8 zeros, 1, 0. Right. And 2, 7 zeros, 1, 0, 0. This is called what? One hot encoding. Because not to give weightage for all. So then I will be doing one hot encoding. So as one hot encoding format, and then if I display after one hot encoding, then the digits will look like this. 5. Is this alright now? This is called data pre-processing. Step number 1, any program, same thing. Any program, same thing. Step number 1, import libraries. Step number 2, data pre-processing. In data pre-processing, splitting them into training and testing set. And data normalization, if you want to do, you do. Or one hot encoding kind of thing. This and all comes under what? Data pre-processing. Then after that, I need to define the neural network. What was the neural network I designed for it? 784, 512, 256, 10. That I can do it here. Modal, sequential, one after another. Okay? Modal dot add is what the function we use. Modal dot add, and this is sequential. From where sequential is imported? Here in the first, we have done import keras.modal sequential. So from keras library, we are using the neural network. Okay. Right. So what is the input shape? 28 cross 28. So how many neurons would be? 784. Next, modal dot add dense. The moment I say flatten, in the input node, no processing will happen, right? The processing will happen in the hidden layer. What do you mean by processing? Multiplication with weight, addition, and activation function, non-linear function. This happens in the hidden layer. So that's why it is flattened, then dense. What is the activation function used here? Sigmoid. Right. Then modal dot add dense 256 activation function sigmoid. And modal dot add dense 10 and activation function softmax. Multi-class classification when you do, you use the activation function softmax. Only two classes means binary. Binary, here you use categorical cross entropy. Binary cross entropy is the word you use. So when it is only two classes, in the output layer we use sigmoid function. When multi-class, we use an activation function called softmax. I'll tell you what it is. Right. So I create a model. Right. I create a model, and then and I want to see the model history. What was the neural network? Input 784, no weights. And dense 512, another dense 256. So how many hidden layers? One input layer, two hidden layers, one output layer. Correct? Now 784 into 512, the total number of weights are 4,01,920. You multiply and see. Multiply. Multiply. Are you getting the same? If you have a mobile phone, you can use. So you are getting wrong. Yeah. So how many weights were there? 784 multiplied by. Wait. 784 into 512. 4 lakh 1,408. You got a difference. Now, in hidden layer, you have weights, and each node is associated with what? Okay? Each node is associated with a what? Bias. So how many neurons are there in the hidden layer? 512. So how many bias? 512. Add 512 to this. So how many parameters? Weights you need to update, bias also you need to update. So B1 old is B1 new is B1 old minus again error function by dou E total by dou B1. Again bias. This point is clear? Right. And now how many weights here? 512, 256. So 12 multiplied with 256. So 256 plus 256. 1,31,328. And here in the output layer, how many neurons are there? 2,560 plus bias. How many bias? 10. 2570. Is it all right now? So this is what design of neural network. And all these will occupy a space of 2.04 MB. And total trainable parameters are this many. And now, the total error which we used in earlier case is mean square error. We have taken square of the error, and then we have each one we get error na, mean square error. So here it will be used a loss function categorical cross entropy. Categorical cross entropy. అయిపోయింది కదా. మామ యొక్క 10 ఎకరాలు గుర్తుకొచ్చాయి అనుకోండి హిమయసాగర్లో. 1 ఎకరం 4 కోట్లు 5 కోట్లు 40-50 కోట్ల ప్రాపర్టీ. No weight, no neural. If mama is not having property, then only program, Python, Colab. Yes sir. If you have farmers, no issue. But one thing, you have a very good property of your mama. 40-50 crores you have. Let us take you got married. Mama gave another 10 crore, 60 crore. Every day you are sitting at home and then eating nowhere, you are going outside. Are you valued? See, then also problem. Wife says, Buddhi leda niki, uchan tindaniki, that what? Right? Now, if let's say after 2 to 3 years you get married and get every day you are at home only, the son is going to school, you are not going anywhere. How it look like? Because no Python you learn at BCA. Learn. You learn or you leave, that is up to you. Right. So categorical cross entropy is P1 into log of probability of that P1 becoming to that particular class minus 1 minus probability log of 1 minus probability is what the cost function we use. The cost function we use is error square, mean square error, mean absolute error, categorical cross entropy, binary cross entropy. These are the things. Binary cross entropy, 2-class classification. Breast cancer is there or not? There or not? Output is only 1 neuron. Use cost function, binary cross entropy, but here it is categorical cross entropy. And the algorithm which you can use can be ADAM or SGD. SGD stands for what? Stochastic gradient. Gradient slope backpropagation, which we love. So now this if you try to do, then you are fixing up the parameters, and now you are training beta 1, 2, 3, digit 5, labeled 5, learn, update weight, digit 2, update weight. So like that you try to see here. I am using Google CPU, Colab CPU, and it is taking 11 seconds. How many iterations I am going? 5 iterations I am going. And I am using accuracy. So first iteration I got accuracy 68.59, second 0.908. See, if you are learning, not learning now, after 10 years you think of your kid. He is going to tuition, not at all he is learning, then you say, Baito, needs kora. That is what I am doing now. He is not learning means what we say, beta, kuchora, chocolate pistara. So then we say like 1, 2, 3. Table, my son is in 6th class. Very difficult of learning table. I say 6 paisa. Suddenly I ask, Papa, no. Means what? Not properly trained. So it is training now. So here we do batch processing. What do you mean by batch processing? Total 60,000 images are there. 60,000 by 1875. Means images little bit ahead if I go, you will be out. See, I will run it again, I will show. How much time it is taking? Total 1020, total 1875. I am not giving all 60,000 in one. 32 images, one batch, like that. How many batches? 1875 batches. This is called batch process. If you are interested in, I will explain, otherwise we will. Because for BCA, if you are interested, then it's okay, otherwise. So it is taking time, so almost, and when you change to GPU, it will take less time. TPU, much less time. Right? So this is EPO. 94, 94, 95, very good, no problem. And so this is, for other applications, mounting Google Drive. If I give you from Medicity Hospital, I will download a CT scan and then do for classification breast cancer. Then if that is not available there, you cannot import from the libraries. Then what you need to do? You have to put it in your Google Drive. So you have to upload this data in your drive. So try doing this. Okay. So then after that, I am predicting. I am giving X test, some X test, and I am predicting. So when I predict, then I can display. Right. So the data was from testing. I gave some sample. So 7 was there, but it is predicted 7. 2 was there, predicted 2. Right, because 95% accuracy is what I got when I train neural network. This is called ANN, Artificial Neural Network. And same thing, so I'll stop here. And now this paper can be solved by you, and then you can, very good journal, Springer Journal. Prediction of breast cancer using artificial neural network. The author is from India. Where? Turkey. The author is from Turkey. So instead of MNIST, he has taken breast cancer is very severe problem in ladies. So this is a CT scan. So you can take data from hospital and it can be labeled, different breast cancer pictures would be there which are labeled, but in reality they are not labeled. Cancer, see, how many stages of cancer? Early stage or middle stage, that is what you need to do, which is called BIRADS, which is of the current order of the day in research. So like this you can take any data, program is with you, in any collab you can find this program. Only thing what you need to do now, change application and do it, very easy, right? So this is what artificial neural network which is solving the problems of real time, which is called computer vision biomedical application, your FDP name actually. Okay, if you have any question you can ask me, or otherwise we'll break for lunch. And here computation, see, I have shown you the computations. So computations are huge. You can reduce the computation by using a new this thing. So malignant means it can be classified as cancerous or non-cancerous. So you can take, and now when you are going for your campus placements, you do projects, write report. Each project will occupy half a page in your resume. Half a page in your resume. Okay. Our students would be around 3 to 4 pages resumes. Then you can write, I know Python, I know Keras, hey, I can do programming, is what you can write. And I did a project for biomedical application, is what you can write, which attracts the interviewer focus. You do something, get a research paper and then publish. Last year when I am teaching my second year BTech students, we got 7 international conference papers from just second year BTech. Okay, so if you want to know about me, then what you can do, you can put my name in Google and then who I am and then what kind of research I do. See, our teachers used to say, na, Charitra Putallo mana peru undali. In history, our name should be there. What is history? Google. If you type your name in Google, what you get? Facebook page. Right. So this is about me and about my researchers, and my researchers are referred by how many? Outside in the world. So this paper of mine is referred by 290, and this 290 is not my relatives. When it is come in Google, okay, these are from, these guys are from outside. They are from different country. So when your names are there in the Google, then you may feel like my name is there in the history, right? So this is, these guys are from which country? The authors are from, some other country, not from India. So like this, your papers, if they are getting referred by outsiders, okay, then you can, so these are the authors actually. Abulik, they are from, you can download and then you can see their country actually. So when we are in school, our teachers used to say, it's Adavandra, right, Mahatma Gandhi, right, and Kandukuri Vireshilingam and all, we say, right, their names are there in the literature, why not your name? So your Google tells you who you are. Okay? Alright? Any questions? Yeah. Mama is calling, huh? Alright? Okay, so we'll break it now and then we'll meet at 2 o'clock for CNN, which is the day, the current trend, deep neural networks, convolution neural networks. Okay? Very easily I'll introduce the concept. Thank you.